This lesson is about the density equation and how to do density calculations, and by the end of this lesson you should be able to use and rearrange the density equation. So before we start, have a little think about density and the particle model. So what I'd like you to do is draw a model of the particle arrangements in a solid, a liquid and a gas, and then think about which state of matter is the most dense and see if you can explain your answer. So the definition of density is a measure of the amount of substance per unit of volume. So in other words, how tightly packed something is, how many particles there are in a given space. So if we look at a solid, a liquid and a gas, we can see that in a solid we have lots of particles in the same space, and so those particles are really close together, and so that makes that more dense. If we go down to the liquid, we can see that the particles are slightly more spread out, they can flow over each other, and there's less particles in a given space, and so that makes that medium density. And when we come to a gas, for the same volume, we can see that there's less particles within that given space, and so that's less dense. So solids are always more dense than liquids. Liquids are more dense than gases. Now there is one notable exception to this, and that exception is ice and water. So ice has got a different structure, and so the ice will float on top of water. So let's look at how we calculate density. So we've already said that density is the unit of volume of a substance, and you can see the measurements there is kilograms per meters cubed, and we need to work it out by dividing the mass of an object in kilograms by the volume in meters cubed. We can write that equation down like that. So density equals mass divided by volume. Or you might often see it written down like that as well. Now the units here are really important. So we're going to look at the units. So there's our triangle, and we're going to use that in a little later. But our units are important. So volume is measured in meters cubed. So that basically means if we were looking at a solid, we'd be looking at an object where all of the sides were a meter in length, so meter cubed. Mass is measured in kilograms, and so that makes the density kilograms divided by volume. So in other words, kilograms per meters cubed. Now we can also use grams and centimetres. So if our volume is in centimetres cubed and our mass is in grams, then we can actually use grams per centimetres cubed. So have a little practice at some of these equations. This is just a really simple plug-in equation, and what I'd like you to do is have a look at the density of solid iron and the density of an iron block once it's been melted, and it's the same iron block that we've now melted. So we plug those into the equation, we get 79 divided by 10 equals 7.9 grams per centimetres cubed. And notice that this is just a unit, so it's grams, and this unit of centimetres cubed makes up the unit for the density. The next one, after it had been melted, well, we still had 79 grams, but this time, because it's melted, it's taken up more volume. And so when we divide that, we get a density of 6.99 grams per centimetres cubed. So you can see quite clearly there that the solid iron is a lot denser than melted iron, than the liquid iron. And so that's the reason that these values are different. So the liquid, because it's got a bigger volume, is going to the particles got more energy, so they're free to move around, they take up more space. The mass doesn't change, but the volume has increased, which means that the density has decreased. So the next thing we're going to look at is how we rearrange this equation. So we start off with our triangle. Now remember, with our triangle, the quantity that we're trying to find is the one that we're going to cover up. And remember that this line is your divide line, so the line through the middle is the divide line, and this line is a times line. So if I want to find out mass, I just cover up the mass, and that gives me density times volume. So that's our equation for mass. If I want to find the volume, again I cover up the volume, and that leaves me with mass divided by density, and that's our third equation. So hopefully you'll now have an understanding of how you use and how you rearrange the density equation. And the best thing to do for these is just practice, practice, practice. Find as many questions as you can and practice using and rearranging this equation.